Okay, we're going to continue with our quadratic functions, but we're going to look today just at the graphs. What are some of the features of the graphs and how we can do some of this stuff on our calculators. So we'll start again remembering that a quadratic graph is our U-shaped parabola graph, and remember the a numbers. So in this case it's -1/2, so that meant it was upside down and a little bit wider. And you can see our vertex would be at -1 and 2, so that means we'd go to +1 and 2. So we have our vertex there, and we chop things in half upside down, so there's our graph. So what we're going to do today is go through the features and kind of tell us what that means in terms of the graph. So the first thing we looked at already is we know that if a is positive, the graph opens upwards. If a is negative, it opens downwards. So looking at this equation that we got as an example, we know that we have it opening downwards, right? So, oops, let me pick a different color here that's a little bit better. Okay, so we have opening down for this graph because of the negative, and the a value is a vertical stretch, so that means because it's 2 in the equation, that means we would say vertical stretch of 2. So remember what that means then is based on our graph, we would have upside down graph and it'd be a little bit skinnier than normal, something kind of like that. Okay, so that's it for those parts. So now the second part, remember, is our P and Q. So in this case we have a 3 and a 4. So remember the P value is opposite, so that means our vertex would be at -3, -4. So I drew this wrong how I had it here, so let me erase this graph and kind of resketch this a little bit better. Okay, so we know our graph then would be, our vertex is at -3, -4, so it's going to be down here somewhere. We know it's -2, so that means we're going to be upside down and a vertical stretch of 2. So what we're going to look at now is what the domain and range is of that. So we know just by looking at this graph that our range is going to be telling us, our up and down is going to tell us whether we have a max or min. So in this case, because it's opening downwards, we have a maximum. So we have a maximum value of -4. That's as high as it goes. So because of that, we can say our range then is less than or equal to -4. If our graph happened to be the other way around, if it was going upwards, that would give us a minimum. So then in that case, we'd say something like our range is a y value greater than or equal to +3 or 4, whatever it would be in this case. Okay. And the next one we got here, it's still the same equation. We're just continuing. So because we're dealing with our graph again, remember it looks something kind of like that. It goes on and on forever in the horizontal direction. So we would just say our domain is XER. So that's the same for all of these graphs. And remember our vertex was at -3, -4. So remember we have an axis of symmetry that would cut this graph in half. And that's going to be located exactly where the vertex is. So in this case we would say our axis of symmetry is at -3. So remember our vertex tells us not only the axis of symmetry, but it also tells us our range. So we get the -3 as our symmetry, -4 would be our range value. Now the rest of it is, it's asking what's our x and y intercepts. So you can see for this equation we don't have any x-intercepts. So in this case we'd say there's none. But if we were trying to solve them, if they did have some and we're trying to solve them, what we do is we plug a 0 in for y and solve the equation for x. Our y-intercept, a little bit easier, we want to plug in a 0 for x. So in this case we'd have y would equal -2 times 0 plus 3 squared minus 4. And you can type all of that in your calculator. 3 squared is 9 times 2. -2 would be -18 minus 4, so that would give us -22. So if we actually extended this graph down low enough, what that's telling us is it would cross the y-axis at -22. And we can write it as just that, -22, or sometimes it's better just put it as a coordinate. So we'd say when x is 0, y is -22. Our last thing with x-intercepts, you can see in this case we don't have any because our graph is upside down and it's below the x-axis. So there will be times where you get 0 x-intercepts, there will be times where you get 2. So if you look at this one I just drew, we have 2 different x-intercepts. And it's also possible that you'd only get 1 if the vertex happens to be right on the x-axis. So we could get 0, 1, or 2, and that's going to just depend on whatever the equation is. Okay, so let's go through a sample graph and we'll go through all of our different properties. So here again, this is our y equals x squared. That's our regular graph. So let's graph this new one now. So we know our vertex is going to be at 3, 5. So we're going to go over 3, up 5. So somewhere about there. And we know it's going to be upside down and a little bit skinnier, a little bit like -2. So let's just estimate our graph something kind of like that. So let's go through all of our features. So we know it opens down because of that negative. And because it's opening down, we know we have a maximum. And that maximum is going to occur at our vertex of 3, 5. And from that, we know our domain is going to be any real number. We know our range is going to be less than 5 in this case, because that's our maximum. And we would say our axis of symmetry is going to be right at the center line, which would be at x equals 3. So that takes care of most of the features of the graph. So now the only other thing we got to figure out is our x and y intercepts. So we can see our y-intercept. We can calculate that mathematically. So let's put a 0 in for x. So we'd have 0 minus 3 squared plus 5. So if we crunch all that out, we get -3 squared is 9, times -2 would be -18 plus 5. So that gives us -13. So we have a y-intercept at 0, -13. So if we continued this graph on and on forever, we would cross somewhere down there, down at -13. And our x-intercepts, you can see in the picture we have 2 of them. So let's figure those out mathematically. So in this case we put 0 in for y. So we'd have 2x minus 3 squared plus 5. So to solve this equation, we want to bring the 5 over first. So that'll make it -5. Then we want to divide by -2. So that'd be 5 halves or 2.5, whichever we want. X minus 3 squared. So the next step is to get rid of that square. We want to square root both sides. So that'll cancel that out on that side. So we get square root of 2.5. I'll just leave it as a decimal like that for now, and that would equal x minus 3. But we got to remember, when we square root a number, we actually get a positive or a negative. They'll both work. So on your calculator, what you want to do is go square root 2.5. That gives us... Yeah. Okay, so on your calculator, if you go square root of 2.5, you get 1.58, but remember we should have plus and minus. So that means we'd have 1.58 plus 3 equal to x. That would give us 4.58 for one of them. And the other one would be negative 1.58 plus 3, which would give us 1.42. So that means that's our 2x intercept. So you can see on our graph we should have 1.42, so I'm a little bit off on that one when I guessed. The other one's 4.58, so that one's a little bit off too, but you get the idea. So you can see this graph, those are our x-intercepts, and we know our y-intercept was -13, so it should look something a little bit more like that. But that's it. So you get the idea of sort of how we can figure out what these graphs look like accurately without relying on your calculator. So what we're going to do now is actually figure out how we can do these on our calculator. So the first thing you want to do is be able to enter them in on your calculator. So you want to go to the y equals. So up in the top corner, go to y equals, and we want to type in the equation. So let's do this bottom one here as an example. So you can type this in as we go through on the notes. So go to y equals, put in -3 brackets x plus 1 brackets squared plus 3. Hit graph. And sometimes you won't be able to see the graph completely, so you want to be able to see the vertex, the x and y intercepts if you can. If you can't, change your window settings. So go to window and move them bigger, small, or whatever. Or if your window settings messed up, hit zoom standard, and that'll get it back to normal. So when you do this, you should get a graph looking something kind of like that. So that's the first part, get our graph figured out. So now let's figure out how we can figure out what the calculator is going to give us for our vertex. We already know from the equation that our vertex should be at -1, 3, right? That was our P and Q. But let's try this on our calculator to see if it works. So go second calc, so that's the button up at the top by trace. Hit second calc. Let's choose maximum because we know it's upside down, so it's going to be maximum. you have to tell your calculator you want to go left and right of that vertex. So move your cursor over so it's left of the peak, hit enter, go right of the peak, hit enter again, and it gives you your maximum. So on my calculator, I'm getting negative 0.99999. So calculator has a little bit of trouble estimating sometimes, so just round that off to -1, and it gives me a y of 3, which is what we know the right answer should be. So no matter what the equation is, you can always use second calc max or min in order to figure out that vertex. So now let's try the y-intercept. So this one, if you go back to second calc, value is the easiest one to figure that out in, and all you have to do is put in a 0, because we know when x is 0, we should have a y value of something, and in this case, we get 0, 0 as our coordinate. So that one's really easy to solve for. To get our x-intercepts, it's a little bit more difficult because we can't put in a value of y of 0. It would be nice if we could, but your calculator's not programmed that way. So what we have to do is actually figure out where those x and y intercepts, or those two x-intercepts are manually. So go second calc 0, and in this case you got to move your cursor left and right of each 0, which is kind of above and below the x-axis. So if we go to the one on the far left, hit enter, go above the line, hit enter, enter again. That gives us -2 and 0. That's one of them. And we could do the second one the exact same way, so go left and right of the second one, and that gives us 0, 0, which we already had as our y-intercept. So in this case, we would only have to do the 1. And that's it. So by knowing all of those things, we get a pretty accurate sketch of our graphs. We know our x and y-intercepts are at 0, 0. We know our other one's at -2. We know our vertex is at 1, 3. So our graph would be upside down, something like that. And we know that it opens downwards. We have a maximum at 1, 3, -1, 3. We have a domain of XER. Our range would be less than or equal to 3. We'd have an axis of symmetry of -1. And that's it. So we'll do some practice questions like this on a worksheet, and we'll be looking at other types of equations and converting things as we move on.